All right, thanks so much. So welcome to Improving the Security Posture of macOS and Linux with Azure AD. I am Mark Morowczynski, and I'm here with Michael Epping. We are both product managers in the identity division here at Microsoft. We work on a team called the Customer Experience Team. So we work with customers on their deployments of Azure AD, and we take the learnings and feedback back from those deployments to work it back into the product to make it easier and better for everybody else. So this is our contact information. If you want to get a hold of us, we're both pretty active on Twitter as well as Mastodon. And we got a lot of things we're going to try to cover in this session. So first, we're going to start by just kind of doing a quick level set of what is Azure AD and conditional access, why prompting your users might not be the same security benefit that you think it is. And then we're going to cover some things around Azure AD and Linux servers. And then we're going to move to the client side around Macs and Linux clients. So for Azure AD, for those that aren't aware, Azure AD is not just an identity provider for Office 365 and Azure. It's actually a full-blown identity access as a service solution. So you can connect to other SaaS applications like Google, Dropbox, AWS, but it's much more than just that. It lets you do things like self-service group management and self-service password reset. It has governance capabilities. It's a full-blown identity access as a service. And this is becoming more and more important as more resources are moving from the on-prem network up to the cloud. So no longer the days of saying everything on inside the corporate network is safe and everything everything inside the corporate network is safe and everything outside is bad. And the resources that people are accessing are no longer just from corporate devices on the internal corporate network. People need to access these Concur and Dropbox and DocuSign, things like that. And they're probably coming from different devices, no longer just the corporate device. They're using their personal iPhone, like BYOD scenario. So we can no longer have this like very strict, firewall, everything on the corporate network is how we're going to protect it. It actually moves to more of an identity-based thing. And if you've heard us talk about Azure AD before, you may have heard us use the phrase identity as the control plane. Now, from an Azure AD perspective, there's a lot of things that we can talk about, but the thing I want to just really focus on for this talk is that Azure AD is built on open standards, things like OAuth, OpenID Connect, SAML, and SCIM. If you actually look at many of the Microsoft cloud services, they're actually built on using OpenID Connect. And we're continuing to invest in new standards, things like FIDO and Decentralized Identities Framework. And you may have seen the announcement that we made with Apple and Google around passkeys. So we're continuing to invest in these areas. But the reason why this is really important is because that if you have applications that speak these protocols, you can integrate them with Azure AD pretty quickly. And that allows you to use things like conditional access. So conditional access is one of our most popular features. It's our zero trust authorization and authentication engine. It's evaluated every time a user goes to access a resource before an access token is granted. They have to pass their conditional access policy. And there's lots and lots of controls you can do in conditional access. So you can create policies that say, if they're off the corporate network, maybe we want to do something different. Maybe if they're coming from a location that we don't have any business interest in, we want to block. We can do risk-based policies, so we only prompt the user for MFA when there's something risky, like they're coming from a location we've never seen them come from before, or they're coming from a device that we've never seen them come from before. We can also start to look at the state of the device, and this becomes more important as we adopt those zero trust principles. We focused a lot initially on the user identity, but that device identity is becoming more and more important. And the question you should be asking yourself is, how do you verify the state of our Linux and Mac clients? We can also do things around application requirements. So conditional access policies are applied to the service principal, and we can do things like we want to do certain things if they're coming from a browser, or different things if they're coming from a desktop or client app like Outlook Mobile on the phone or on your desktop. But some of the resources that your users are probably accessing might also include Linux servers as well. We want to make sure we're applying conditional access policies to that. Now, from a conditional access policy perspective, these are evaluated a little bit differently if you're used to the on-prem group policy Active Directory, like local, site, domain, and OU precedents. It does not work like that for Azure AD conditional access. All policies that are in scope of the request are actually ANDed together. And then the first control we look at is a block. If block control will always win, so if there's no block control, we then move over to the grant control. And the grant controls are applied in this following order. First, we look at risk. Then we look to do MFA, we look at the device status, and then we look at approved client app protection. Has to come from an Outlook mobile client, so that way they can't accidentally save resources over to like their personal OneDrive or personal Dropbox. It has to go to the corporate OneDrive or corporate Dropbox. Now, the important thing to remember with conditional access is that it will try to satisfy the controls without requiring the user to do any interaction. So if you have a conditional access policy that says that you either need to perform MFA or come from a compliant device, if that device is compliant, they will not get prompted for MFA. But if they're coming from a non-compliant device, like here you can see that in the sign-in logs is compliant is set to false, they would then get prompted to do MFA. And this is becoming more and more important as you understand your conditional access policies, because this will have a big impact on your end user experience. So if you're not on the identity access management team and you know what your conditional access policies are, you should go talk to them and figure this out, because this will have a tremendous impact on what your end users see. So some common policies we see at a lot of customers are things like requiring MFA for all users, which is really good, blocking legacy authentication, blocking countries that we don't operate in. And then we start to also require things like coming from a compliant device or coming from a hybrid joined device if it's on Windows 10 or Windows 11. And then we also start to see some customers adopting the opposite of that. So if you're coming from a non-corporate device, we want to have a more strict sign-in frequency. This is always kind of like sometimes you hear this like the grandma PC scenario. I don't know why people talk about this, but like, you're at your grandma's house and I'm sure she's got like a rockin' new Mac studio, so you want to get some good work done on that. I don't know if you're fit with your family, spend time with your family, don't do work, but I get it. They want to start to require more stricter controls if you're not coming from a corporate device. So they'll say, okay, every 2 hours you need to log in. And if your Mac clients and your Linux clients are not able to show this compliance policy, they may be getting caught in this more strict policy, and they're probably having a really poor experience. They're getting prompted all of the time. And when you talk to your security team about this, they might say that that's good. This is good from a security perspective. They'll say we practice zero trust here. We don't trust any users. We don't trust any devices. We don't trust any applications. We don't trust anybody. More authentication prompts is good. It's good for security. You want people to prove who they say they are. And in theory, that sounds like that would be correct. But in practice, what we're seeing with customers, it's probably actually having the opposite effect. So if you're over prompting your users, you might be putting them in a really bad state. You're kind of training them to do the wrong behavior. So let's take a look at why prompting is kind of bad. So here's a case study. So one of our customers, European customer, they were doing their red team attack, right? They're running the red team playbooks, password spray. So right now, if they're doing it, it's winter 2023 exclamation point, rip it across a bunch of their clients. They're going to get some accounts compromised. So they had some, and they asked, hey, can we just like hammer these people with MFA prompts and see what happens? Like they should report this. And their management said, okay, sounds good. You can go ahead and do this. You have approval. So they did. And here is what the result was. First of all, nobody reported anything was weird to the help desk. So that is not good. Many users actually just blindly approved those MFA requests. That's even worse. And then someone was so fed up with the number of prompts they were getting on the Authenticator app, they actually just removed the Authenticator app completely from their phone. So that is a really something we don't want people to be doing, obviously. So this over prompting is a real problem. We need to make sure we're thinking about it because we're training people to do the wrong thing. This leads to compromise because when they get 8, 9 or 10 prompts a day, which is a lot, and then the attacker goes to log in, they get that 12th or 13th prompt, they're just going to hit approve, right? So we don't want to prompt over a prompt. We only want to prompt when absolutely necessary. And not only is it bad from a security perspective, it's bad from a productivity perspective. And this is especially bad on platforms that don't do any single sign-on out of the box, which is very common for those macOS users. And we'll talk about some things we can do to improve that, but they might be out of the box, be starting in this pretty bad state. So really what we should be focusing on here is we should be striving to improve our user experience and improving security. So we only want to prompt our users when it's truly needed, like when they're coming from a device we've never seen them come from before, when they're coming from a location we've never seen them come from before, when their risk status changes, that's a good time to do a prompt. And the types of authentication prompts we want people to be using is passwordless-based credentials, because when we do prompt them, we want it to be as less impactful as possible. And we talk about prompts here, and I know most customers probably have a majority of their environment is Windows, but pretty much all the customers that Michael and I work with, they have some Mac users and they have some Linux users. And because this experience is really poor, they tend to exclude these users from these conditional access policies. And the people that tend to use these devices are the executives that have access to very sensitive information. They're the security team that has access to very sensitive information. And there are developers that are doing our code stuff. And those are the people we need to be protecting the most. But because the experience is bad, we end up excluding them from those policies. And we need to stop doing that. So we're going to kind of cover some things to do where you can improve that security, but also make this a good user experience for these users. So the first thing you need to determine is, do you have a prompting problem in your environment? If you don't know, the answer is you probably do. And you're going to figure out if you do by looking at the data. And all the data that you need is in the Azure AD sign-in logs. And if you go to ak.ms/MFA prompts workbook, We have some pre-built dashboards for you, and we'll show you things like which users are being prompted the most. And for many customers, this is sometimes very surprising. Which applications are causing the most prompts, and it's probably going to be those collaboration apps, but every once in a while you'll find an application that has an extremely high prompt count that you were not expecting, and maybe the application is misconfigured, or maybe it's not behaving correctly. These are things we should be investigating. And also, what is the device state of our devices? Here you can see that 95% of these devices in this tenant are showing up as unmanaged, so they would be getting caught by those more restrictive policies, if we have them, enforcing re-authentication more than we actually need to. So this would be something we want to go ahead and take a look at and fix. So start with this to see where the problems are in your environment and start to remediate, which is what we're going to cover here next. So Michael's going to talk about what we should do in the Azure AD and Linux server space.
All right, so let's start with talking about Azure AD and Linux servers first. So like we said earlier, resources can be things like web applications, but it can also be things like servers. So we definitely want to think about how are we properly securing that access to servers, and how are we integrating that with our identity and access management and zero trust engine like conditional access. So we want to make sure that we're applying these same types of security controls, compliant device, MFA, etc., if someone's logging into a server workload. So I want to step back and talk about why Azure AD login for servers is important. And so if we think about the way that people access Linux servers today, it's typically via SSH. And for a lot of organizations, this looks like one of several options. One might be just using a local username and password, and then just sending that username and password to the server, and the server lets you in. Another way might be integrating that server with an on-prem directory, like an LDAP directory or some sort of Radius instance. Another method might be Kerberos-based. And then the other one that we see really, really commonly is public key, private key pairs, where you have a key that's on the server and a secret key that's on your client, and you sign some data with the secret key and you send it to the server, and the server validates it. And if everything's in alignment, then the user's allowed in. There's a couple other options that we see organizations use, like user certificates from a PKI, but most commonly we see the defaults used for whatever the distro comes out of the box with, which typically means username and password or public-private key pairs. There's a lot of challenges that come along with using things like the passwords or the key pairs. So most Linux distros assume one of these two out of the box, and in addition to that, you need a lot of infrastructure to manage these properly. So if you're doing centralized management of the accounts, that means that you need to have LDAP and Radius infrastructure that you maintain. Or if you're distributing keys across all of your different servers, you need to have infrastructure in place to not just distribute the keys, but then revoke them at the right time. Like if you're offboarding a user, do you have systems in place to actually go and make sure that any key that they had access to got revoked? And for a lot of customers, it's a very difficult problem to solve. In addition, Linux does not have support for some of the more modern protocols for authentication, like WebAuthn and FIDO. And this can lead customers into using the default methods, which can either be very weak in the case of passwords or hard to manage in the case of keys. And there's also no device-based controls that are typically available. So a lot of customers are primarily using network boundaries to protect their server workloads. So we're not using that health of the device as a criteria to determine should someone be able to access this resource or not. So we do have a solution for different server workload options using Azure AD. So the way that this works is that the user is going to use their SSH client, and we'll talk more about some of the requirements for that. And just like accessing any other application, they're going to authenticate to Azure AD, and Azure AD is going to check if they're authorized. So we can check to see, did they do an MFA? Is their device healthy? Do they have the appropriate role to access the virtual machine that they're trying to get access to? And then if everything checks out, instead of returning an access token like we might if they were accessing a web application, we actually return an OpenSSH certificate. So this certs is something that OpenSSH already supports. So in this case, we're just issuing a cert from Azure AD instead of that access token. The client can then present that certificate to the server, and if everything checks out and the server trusts the certificate, the user's SSH tunnel can be established. So if your VM is running in Azure, this is a generally available feature for anything that's in Azure that's running Linux. And if your VM is outside of Azure, we can provide the same functionality. So if you're running Linux workloads in AWS and GCP in your on-prem data centers, we can provide this same functionality via an integration with Azure Arc. And this is a public preview feature. So let's talk a little bit about the requirements and then how this actually works under the hood. So one is the client has to be using OpenSSH. So we're building all of this on top of the modern OpenSSH client and server. So the client needs to have the proper client bits. We're also recommending that you use our tool called AZCLI. So AZCLI is important because it comes along with Microsoft's auth libraries. And this is what's used to get that user certificate that you're going to present to the server. There's also an extension for AZCLI called our SSH extension that has to be installed as well. There's many different distros that support AZCLI. You can install it on most Linux distros. You can install it in a Docker container, Mac devices, Windows devices. You don't have to be running Linux as your client. The client must be able to reach the VM on the SSH port for the case where the VM is in Azure. So this could be over the open internet. We wouldn't really recommend that. And it could be over your site-to-site VPN to Azure or using Azure Bastion as a gateway in between your client and the VM, or using Cloud Shell in the Azure portal. On the server side, there's a couple requirements as well. Like I said, the VM has to be running in Azure for our first example. That Linux server has to be running a supported distro. So we do have an up-to-date list of the distros that we support on our docs page. The Linux server has to have OpenSSH server. So this is pretty standard for pretty much any server OS. And then there's a couple endpoints that Linux server needs to be able to reach. So some of these are endpoints for installing the software that we need on the server. Some of them are some Azure services like the Azure Instance Metadata Service. And then some are Azure AD endpoints that are used to validate the certificate. One other thing to understand is that the server has to be represented with an identity in the Azure AD directory. And so the type of identity that the Linux server will be represented by is something called a system assigned managed identity. So this has to be turned on in order to make this whole thing work so that there's a object in the directory that represents the Linux server. And then the server has to have our software package installed. Let's take a look at how this actually works under the covers. So the first thing that has to happen is you have to install our VM extension on the server itself. So there's a couple modules that come along with this, and you'll see how they're used in a second. On the client side, we have to have AZCLI, which comes along with the Microsoft Authentication Library. Then, when the user actually wants to connect to the server, they issue a command saying, I'd like to connect to server such and such, and MSAL is used to go to Azure AD and request one of these certificates. Again, we do all the proper authorization checks. So we see, is the client healthy? Did the user do an MFA? All of those sorts of things. If everything works out correctly, the user is given a certificate. So this is a 1-hour SSH cert. So just like an access token, it's very short-lived. And then this is passed to the OpenSSH client, which then sends that certificate to the OpenSSH server and waits to see if the tunnel is going to be established. The VM then passes the SSH cert to our software that was installed previously. The first thing that happens is it checks with the metadata service to see if the cert is valid. So we need to make sure that it's signed by the Azure AD tenant and that it's not a forgery. And then the next thing that happens is the metadata service is used to check and make sure that the user has the appropriate role on the VM. If everything checks out and we get the thumbs up, then the SSH tunnel is established. So now let's look at the use case where the server is outside of Azure. So a lot of this is pretty much identical, but the main difference here is that the server has to be onboarded to Azure Arc management. So Azure Arc is a multi-cloud management tool that you can install. So we basically just need to have an agent on the server that is used to represent the server in Azure AD and Azure. Then most of the other requirements are the same. We have to have a supported distro. It has to have OpenSSH. The server has to be able to reach the appropriate Azure endpoints. The system has to have a system assigned managed identity. You have to install our server software. And then one of the other slight differences is that you don't actually need to have direct line of sight to the server, but you do have to have Azure Arc configured to allow the inbound connection. So this is different than configuring the firewall of the device itself. You're actually configuring Arc to say which ports you're publishing through the Arc service. And I'll show you what I mean by that. So just like before, we have our Linux server that's running somewhere, this time outside of Azure, and we have our Linux client, or our client that has the OpenSSH client software on it. We install the Azure Arc agent, which then connects to the Azure Arc cloud service. We install the same VM extension on the server side. We install the same client software on the client side. And just like before, we go to Azure AD and ask for our SSH certificate. If we pass all the authorization checks, the cert is returned. And this time, the cert is passed to the Azure Arc service, which relays it through the Azure Arc integration to the OpenSSH client or OpenSSH server running on the Linux VM. So no direct line of sight is required. The Azure Arc service can actually relay all this traffic. Just like before, we need to check and make sure that the cert is legitimate and signed by Azure AD. We need to make sure that the user has the appropriate role in the directory. And if everything checks out, we can establish our SSH tunnel, which is relayed through the Azure Arc cloud service. To actually do the connection is fairly straightforward. The first thing that you need to do is run AZ login. And what this does is it basically just opens your session with Azure itself. So the cloud app you're signing into at this point is the Azure Management Cloud app, and any conditional access policies that apply to that app will apply at this point. You can then specify what subscription you're operating in, so this will probably be the subscription that your VMs are in or that they're registered to. Then, when you want to actually connect to the VM, you're going to run the AZ SSH VM command and specify the name of the VM and the resource group, or you can use the IP address. And this is what triggers AZ CLI and MSAL to go try to get that certificate and initiate that SSH connection. At this point, we do another conditional access check, and the cloud app you're signing in against is actually Azure Linux VM sign-in. So if there's different controls applied to this, we will check for those controls at this point as well. So maybe we check again to see if the device is compliant or that the user's performed an MFA. And with that, I'm going to turn it back to Mark to talk more about Macs.
Thanks. So that stuff's really great. I have some customers using that. It's really, really helpful. So, okay, let's talk about some of the Mac stuff. So when it comes to client-side stuff, there's really two critical capabilities that we want to make sure any client has. The first one is being able to do some sort of device health attestation, and the second is doing single sign-on. From a health perspective, on a Windows machine, there's two options. The first option is hybrid Azure AD join, which doesn't tell us a whole lot. We make some assumptions here. It basically means it's domain joined. There's probably being some group policies being applied to it, but that's about it. We actually don't know any state about the device. The other thing is you could do MDM compliance. Now, for everything else, the only option you have is MDM compliance. There's no other good way to tell what state that device is in. This is becoming more and more critical as more customers start to adopt what is the device identity posture as part of their zero trust strategy. Single sign-on, I talked about why prompting users too much is bad. The user experience and security goes hand in hand. So let's talk about what we can do here from a Mac perspective. To manage the device compliance aspect or the single sign-on compliance, you're going to need to do an MDM. This is the only modern way to manage macOS today. So to do the device compliance, you're going to need to use Intune as an MDM or an Intune integrated MDM, and I'll get to that in a second. And to deploy SSO features, you're going to need to use the MDM to do that. Now, these are two separate features. You can technically just deploy the MDM to get the device compliance, or you could technically just use an MDM to deploy the SSO stuff. You don't have to use both, but we do really recommend you should use both. Okay, so from a device compliance perspective, you either need to use Intune as your MDM, or you need to use an MDM provider that integrates with Intune. You can see the list here. Now, if your MDM provider is not on this list, please recommend they go to this documentation and they can fill out a form to work with our Intune team to get the requirements they need to actually then be a device compliance partner. But without doing this work, your Apple devices, your Mac devices will show up as those non-compliant devices. And if you have more restrictive conditional access controls, they're going to be getting caught by those policies. So let's take a look at how does this actually work. So if Intune is your MDM provider, this is very, very straightforward. There's not a lot to do. Azure AD is aware of Intune, Intune is aware of Azure AD, and the device compliance is sent from Intune to the Intune service, which then writes it over to Azure AD to say, is compliant basically true or false? Remember that sign-in event we showed you? It said, is compliance is false? That's coming from the Intune service. Now, if you're using another MDM provider like a Jamf Pro or something like that, there is a little more work that you need to do to get that compliance status across. But in the end, it becomes very much worth it. Otherwise, you're unable to pass those device compliance controls and conditional access. So the Jamf Pro or VMware AirWatch would send that compliance status over to the Intune service. And then again, Intune would then write that is compliant, yes or no, over to Azure AD. Now, from a single sign-on perspective, there's a couple different ways to do this, and I'm going to focus mostly on the last one, which is the modern authentication aspect, but we're going to kind of just level set for people that maybe are experienced with the Mac space. If you've had a lot of Macs for a while in your environment, you may be familiar with doing an LDAP bind to Active Directory to be able to get access to resources and single sign-on, things like that. Apple is actively telling customers to move away from this and to use Apple's Kerberos SSO extension. This needs to be deployed via an MDM, and this is only really for those on-prem network types of stuff. So this is your like Kerberos, file share, things of that nature. For everything else that's doing modern authentication, you want to use Apple's vendor plugin called Apple's Extensible Enterprise SSO Framework. So if I start getting like tripping over myself later, just know I'm probably talking about this thing. I'll just probably say that SSO framework because that's a lot to talk about. So, okay, so what do you need to do this? First, you need an IDP vendor that supports this, and that's us, Azure AD, we do. And you need to deploy this via an MDM, and you will see why here in a little bit, because this is an extremely powerful thing you can do to the machine. And there's two types here. There's credential and there's redirect, and Azure AD is the redirect time. But let's talk about what I mean by modern authentication. Previously, I mentioned that Azure AD is built on open standards. That's things like SAML, which is good, or even better, which is OpenID Connect and OAuth 2. And the big advantage you get with modern authentication is that it's web-based. So now we can get all kinds of additional things, like we can challenge the user for certificates. We can do things like MFA, we can do FIDO keys, all kinds of good stuff like that. We can actually proxy our traffic through our CASB solution. And if someone starts downloading a bunch of stuff from Salesforce at 1 in the morning, we can sever that connection. All these types of things you can do when the application is using modern authentication. So if you haven't started moving your applications over to modern authentication, you really, really should think about this, because it's a really good way from a security perspective to start adding these additional controls. When you're doing things like legacy authentication, you're usually just limited to just username and password. Okay, so modern authentication, let's talk about how the SSO extension stuff works here. So first, you need an IDP that supports either SAML or OpenID Connect. Azure AD supports both, but there's other IDPs. They may also have similar functionality. You need apps that are integrated with the IDP. This is the applications you're going to get single sign-on. Remember I talked about before, Azure AD is Identity Access as a Service. You can integrate all these apps. That's what you're going to get single sign-on to. The IDP vendor has to create the SSO extension, and the Macs need to be under MDM Manager to be able to push down the right configuration. So let's look at this. So we have our Mac here, and what you're first going to need to do from our perspective is you're going to need to have the company portal on the Mac itself. That is where the SSO extension lives. Now, the end users do not need to go ahead and open the company portal or do anything with the company portal if you don't want them to. I know that sometimes this is a very sensitive subject for many of the Mac admins in the community because they're using a different MDM provider. They're really focused on what the end user needs to do. They don't need to interact with it or anything. It just needs to be there. Then we need to authenticate to Azure AD in some way. So there's a couple ways we can do this. We can open an application like Outlook that will do this for us. We can go to a app protected behind Azure AD like portal.office.com and Safari, or we can have them open the company portal if we want and do the authentication there. And now we'll do our authentication against Azure AD. Again, we're doing modern authentication, so we're able to use those like web-based flows, so we can do things like passwordless with the Authenticator app, or we could do username and password with some sort of other MFA credential. So then what will happen is we'll authenticate over to Azure AD, and what Azure AD is going to send back is something called a primary refresh token. This is going to be used to get you additional access tokens for those resources, and this is stored in the keychain on a Mac. Now, the PRT is good for a rolling 14-day window, so every time we go to get another access token, the PRT refreshes. So if your users are accessing these applications, day in and day out, and coming home on the weekends and things like that, they should not get prompted too often. But it maybe if they're gone for a period of 2 weeks, maybe they're an IT admin that got that 2 or 3 week vacation that we all really deserve. When you come back in, then you would be expected to have to re-authenticate. So let's talk about how this actually works. So the first thing is we need to know if the application is using MSAL or it's doing a browser-based flow. So let's talk about the first one, which is MSAL. So MSAL is the Microsoft Authentication Library. It's an open source library that we made. Most of the, I would say the Microsoft applications use this. Many customers build their line of business applications with this. So we need an application that's going to do that. So we're going to use Outlook here as our sample. So what will happen is Outlook will actually reach over directly to the SSO extension, ask that refresh token to get us an access token. This is sent over to Azure AD. Here, conditional access is evaluated. And if everything looks good and comes back, what we'll get back to the SSO extension is that app-specific access token. The SSO extension then passes that back over to the actual client application, which then presents it to the resource, in this case, Exchange Online. And now we get our email and our Outlook mobile. So they could get single sign-on all the way through using this application with the SSO extension. They didn't have to put any credentials in using that PRT. Okay, but what if my application isn't using MSAL and it's using something like Safari? How does this actually work? So we have Safari here. We have the MSO network stack. Okay, so let's go to portal.office.com or OWA or something like that. So we'll put that in. And what's going to happen is instead of going directly to that, the SSO extension and network stack is going to get redirected over to the SSO extension. And from there, we're going to follow a very similar flow as we did on the previous one. So we'll take that PRT, we'll go over to Azure AD, conditional access will be evaluated. If everything looks good, what we'll get back is an access token to that resource that will go to the SSO extension. This then goes back up the network stack, back up to the browser, over to the application, and now we're logged into our OWA. So this is very, very powerful, right? Because we're intercepting network traffic. So let's look at what we need to do to actually configure this here. So if Intune is your MDM provider, you can go to ak.ms/Apple-SSO-Intune. We'll walk you through the steps to do this. But in order to configure this, you have to configure this from an MDM provider. If Jamf is your provider, we also have directions on how to do this. If you go to ak.ms/Apple-SSO-Jamf Pro, follows a very similar set of instructions, but there is a plist file as well. We recommend to keep it very, very simple when you start, because it's easy to kind of fat finger things we've seen. So just kind of follow our sample, go very, very like basic, make sure things are working, and then continue to add on from there. And then just a few other reminders here. So again, I want to stress that the company portal needs to be on the device, but the users do not need to interact with it if you do not want them to. I know I've said this before, I'll say again, it's because I know this is very, very sensitive for some of the Mac admin community. Now, this other thing here is that the SSO stuff and device compliance are separate. You do not have to do it. You can just do the SSO extension and get that single sign-on, or you can just do the device compliance like I talked about before, but we really do recommend that you do both. Now, another thing that kind of comes up is, how can I troubleshoot this when things are not working? So the easiest way to do this is test things in private mode with Safari, and also go to ak.ms/Apple-SSO-Tshoot guide. While we're recording this, it's in the publication process, so hopefully by the time you watch this, it will be there. But it's a very in-depth troubleshooting guide for the SSO extension. It covers what's in the logs, how to find the logs, how to troubleshoot some stuff. So this is a really, really good resource for you if things are not working the way you think they are. Now, what are some caveats that I need to be aware about this SSO extension? The first one is that the SSO extension is still in public preview, though it's fully supported. We're buttoning up a few things to get this thing to GA. And the apps that will be able to use the SSO extension either need to be built using MSAL or they need to use Apple's system framework. If they're not doing that, the SSO extension has no way to know that anything's being asked of them to go get you that access token. The two primary examples we see mostly asked for in the community are Chrome and Firefox. And the reason those don't work is because they implement their own network stack. So Firefox has some work on their backlog. We haven't really heard anything from Chrome yet, but please go talk to your application vendors and ask them to support the SSO extension whenever possible. Apple is making this more important as time goes on, not less. And the more users we can get using this and getting that single sign-on experience, the better their experience will be. Now, another thing to think about for your Apple users is how about on their mobile device, what we want to do. So the Authenticator app is something we want to really make sure our end users are using whenever possible. As I talked about previously with the company portal and that PRT experience, the Authenticator app will provide that. So many customers have deployed MFA, but at the time it's kind of a struggle to get end users to do things. So they just want to do phone call and text. That's fine. We let them do it. Now we need to move them over to the Authenticator app. So if you go to ak.ms/nudge, there's a way to turn on an interrupt. So when they complete the sign-in request, it will kind of say, hey, you should register for the Authenticator app. And I've had some customers of mine set that to 30 days. And then they set that to 14 days. Then they set it to 7 days. and then 3 days, and now it's set to 1 day. And basically, people that don't register, every time they log in, they'll get reminded, hey, you really should use this authenticator app as a way to kind of force people over to this thing. Now, the other thing you want to make sure we're turning on is number match. That's when you have to type in that number. That prevents some of the MFA hammering I talked about earlier. And the other part here is this is also used as a passwordless method on the Mac. So Michael and I actually have been completely passwordless on our Macs in the Microsoft corporate IT environment since November 2020. So we can do it in this environment. You can do it as well. And sometimes your Mac users are actually some of the better ones to do this with because of the way Macs have sometimes been treated in the enterprise, where you don't have like all these legacy LDAP and these different hard clients that they're trying to get access to. Most of the time, what they're using is actually those web-based authentication apps. So those are excellent opportunities to move them to a passwordless authentication method. So for Mac, what can you use? You can use Authenticator app for number match. You can also use the FIDO keys using Edge and Chrome. Safari will be coming in the future. And then passkeys is something that's an emerging standard that's supported by Apple, Google, and Microsoft. So keep an eye on that as well. So please get out there. Deploy the SSO extension for your Macs, do the device compliance, and start to move your end users over to passwordless to really improve that end user experience. And now Michael's going to talk about our Linux clients.
So the Linux clients are also super important. Like Mark talked about earlier, there's a lot of customers that we have where their developers are on Linux and other people are using Linux for various reasons. And so one of the things that we see very commonly is that people are misconfiguring conditional access when it comes to Linux. So it's important to start by understanding how conditional access identifies what OS a particular sign-in is coming from. And so if you're using conditional access policies that target an OS, it's very common if the device is not being managed by Intune that we identify the OS based on user agent string, which is obviously spoofable. So where possible, you want to make sure that devices are getting enrolled into Intune because that allows us to very accurately determine what OS it is. But in other cases, we want to be very careful when we're using things that are based on user agent string. So our guidance is to have at least one policy that targets any platform in conditional access. And the purpose behind this is to catch OSs that cannot be explicitly targeted in your CA policies. So what this might look like is you might create a policy that says include any device and block access unless the device is coming from, or the traffic is coming from a device with an OS that we officially support, which might be Android, iOS, Windows, macOS, and now Linux is something that we can support as well. So you want to be very careful about what you target. You want to make sure that you have one of these stopgap policies that can stop access from OSs where we cannot identify what they are based on user agent string. And then you can create policies that are more proactive. So we want to make sure that we use device platform in concert with Microsoft Intune so that we're doing things like making sure that our users are coming in from compliant devices, or in the case of Windows, maybe hybrid Azure AD join or compliant. And we have an option to target Linux now as well. So there's some really common scenarios that customers are using the Linux checkbox for in the device platform area in CA. So one of the policies that we've seen a lot of customers do is require MFA on Linux while sometimes requiring other controls on other platforms. So maybe you require hybrid Azure AD join on Windows and MFA on Linux. Or maybe you require your Linux users to be coming from the corporate network. Maybe you apply risk-based policies more aggressively if a user is coming from Linux. Maybe because your Linux devices don't show as managed, you want to target them with those sign-in frequency controls. And now one of our new features is that you can actually target Linux clients with a policy mandating that they're compliant, which did not used to be an available feature. So this one is pretty new. So just as an example of a really common policy set that a customer may have had, is you might create a policy that says, condition 1 is that if the user is coming from Windows, Mac, iOS, or Android, let's require MFA and compliant device. And then in our second policy, we might say, if the same user is coming from Linux, let's require MFA and a trusted location. And then we have our stopgap policy that says, if the user is coming from any device platform other than those ones that we explicitly support, we're going to block access. And that way, if someone's coming in from something malicious that has a different user agent string than what we support, we can block that access. But even better, we want to move towards including Linux in that list of OSs that we're targeting with compliance requirements rather than just location-based requirements or MFA requirements. And so what we have now is two different pieces of software that come bundled together for Linux clients. So one is that we now have a broker that can be used to register those Linux clients with Azure AD. So in the case of Windows, we have what's called the WAM, which can be used to Azure AD join, hybrid Azure AD join, or Azure AD register that Windows client. For Mac and iOS, we have brokers. So Mark talked earlier about the Intune Company Portal being that PRT broker, or the Authenticator app on iOS. On Android, it's the Intune Company Portal. And now on Linux, we also have the Company Portal. And this thing enables us to both register in Azure AD and get the device enrolled into Intune so that we can target it with compliance policies. So there's a couple features that we support today, and then some things we're working on for the future. So today, the main scenario that we're enabling is secure access to those web applications from your Linux clients using Microsoft Edge on Linux. And I'll show you why Edge is a requirement in a little bit. We support Ubuntu Desktop LTS 2004 and 2204, and we also support compliance policies. We don't support configuration policies like we do for other OSs. We've started with just compliance support because it's really critical for enabling Linux productivity. We do also do some basic device inventory and some reporting, so you can see things like enrollment success, enrollment failures. Some of the stuff we're working on for the near future are expanding our support for client applications to things like AZ-CLI, the Git CLI for Azure DevOps, and adding additional support in more distributions. So the way that this works is on your Linux client, you install the Intune Company Portal software that comes bundled with the Microsoft Authentication Library, as well as our broker, which in the case of Linux is built in Java. When the user wants to enroll their device or register their device with Azure AD and Intune, they click a button in the Intune Company Portal that says Enroll Device, and this invokes MCell, which then talks to the Java broker. The Java broker reaches out to Azure AD. We have the user do MFA, username, password, passwordless sign-in, whatever they want to use to authenticate to Azure AD, and then the Java broker will register the device against Azure AD. Azure AD then returns their PRT as well as a device certificate. And then the Intune Company Portal uses tokens gained with that PRT to reach out to Intune and do the Intune enrollment. Intune returns compliance policy, which we can evaluate to see, is this endpoint going to be compliant or not? We return that compliance information to the cloud service, and then we write that compliance information from Intune to Azure AD. And at this point, the device can be used to satisfy compliant device requirements in conditional access policies. Now, when the user actually wants to use the compliant state of their device to access web applications that are protected by CA, there's a slightly different flow. And so you can see here we have our client application, which in this case is Microsoft Edge for Linux, which also has MCell built into it. This MCell piece is really critical. Pretty much anything that wants to talk to the Java broker needs to use the MCell library on Linux. And that's why we're requiring Edge in order to access those web applications. So just like before, the compliance information is being reported to Intune, and then that's being reported over to Azure AD. The user wants to sign in to portal.office.com or SharePoint or something like that. They request a token. MCell reaches out to the Java broker, and then the Java broker reaches out to Azure AD. At that point, just like any other time we talk to Azure AD, conditional access is evaluated. And if everything checks out, like the device is compliant, the user has done an MFA, etc., Azure AD returns a token to the Java broker. The Java broker returns the token to MCell inside of Edge, and then Edge can use that token to actually access the resource. And so now the user can connect to SharePoint Online or Exchange Online or whatever service they're trying to get access to. So this fundamentally works the same way as pretty much any of our other OSs, where we have a broker that's using a PRT and we're enrolling into Intune and getting our device into a compliant state. And so now satisfying those good zero trustee device compliance conditional access policies. And so with that, we have a couple of recaps and go-dos for you. So one is understand your issues with prompting. So talk to your identity and access management team, look at that workbook to see if there's any issues in your environment that you're not aware of. Another one is modernize your Linux server access so that they can be treated like any other resource and be subject to those zero trust policies. We want to make sure that we're requiring device compliance and strong authentication before a user accesses any type of resource, including Linux servers. Integrate your client OSs with the cloud to improve both end user experience and security. So by getting devices under MDM management, we can use conditional access to challenge for healthy devices. And by getting those devices with getting a broker installed on those devices, so SSO extension in the case of macOS and the Java broker in the case of Linux, we can make sure that we're providing users with a nice, smooth user experience. And then use Linux and conditional access policies now, and then start planning for that device management state for Linux. So start thinking about getting your users to enroll their Linux devices into Intune. So Linux as a device platform is now available in conditional access, and you can now enroll your Linux clients in both MDM and get that PRT for SSO. And with that, thank you for your time.
Thank you.